Can you guys see back there? Just want to make sure, because you all look like in a prison lunch table. It's all huddled. Okay, so like Eric said, I am Jay Garcia. I've been working with React Native since January, before it was publicly announced. Who here has played with React Native before? Okay. How many have any published apps out of the group? Okay. Who here would be considered, you consider yourself a JSX expert or someone who's really strong in JSX? Okay, so you guys know way more about JSX than I do. I'm going to be completely honest. I'm very dangerous with JSX though. I focused on technologies like EXTJS, Extension Touch, and enterprise applications. And I was invited to take part in the private beta for React Native shortly after the January Facebook conference. And I can tell you that, coming from the HTML5 world, I've studied a lot of JavaScript. Hey, Wally woke up. Within 5 minutes of working with React Native, I literally just kind of pushed myself away from the chair and I said, holy shit, this is a game changer. I had studied Objective-C for 2 years prior, working with hybrid applications and trying to squeeze as much performance out of the DOM as much as possible, especially on mobile, things like the iPhone 4, iPhone 3s, and so on. And I can tell you from my perspective that I've really gotten tired of having to dig with the web. It's just a pain in the ass. I mean, you deploy an application for your mobile app in the hybrid application, and there's no guarantees that the next versions of the OS that your application is going to work well. You may have layout issues. Huge pain in the ass. You got disparities between the different browsers, different devices. It just gets to be a big pain in the ass. React Native itself brings a new set of challenges to the table. It has its own pain in the asses that it provides. But what I found right off the bat was that if you develop applications using best practices, which are still being distilled in the community and the Facebook team, that your applications can really be amazing. The user experience can really be amazing. And you might find that the application that you have worked on, mainly using JavaScript syntax, net to a native look and feel. And that's what a lot of people strive for with HTML5, and especially for mobile. And we learned throughout the years that mobile HTML5 doesn't necessarily get you that capability, right? You have issues like I said before, disparities between the browsers. Then you also have performance issues. Does anyone here know the biggest issue with HTML5? Just together, what is the biggest bottleneck? Come on, JSX people. You should know this. It's the DOM, okay? Has historically been the DOM. Today with fast browsers like Chrome, using Google Link Engine, WebKit's super fast, Firefox is trying to squeeze as much performance out of his engine as much as possible. It still is the DOM. With React Native, you kind of pull yourself away from all that shit. New set of challenges, but in my opinion, it's a lot better. So today I'm going to talk about, sorry, let me take a step back. The original idea for this talk was to describe to you what it's like to actually create native UI extensions using React Native and show you how to do that stuff with React.js. And as I started to go on that path, I realized I don't know if everybody here actually knows, or there's so much to talk about with just that. I figured that I would just show you guys the basics and how to get. What did Sierra say?
I'm not sure what you said.
She was not happy with my discussion. Apparently she didn't like the direction I was taking this talk. I figured, let me take you guys down the path of what it's actually like to expose native APIs to your React Native application. Let me show you what it's like in the iOS world to give you the capability of have multi-threading and so on. So that's what we're going to talk about. And assuming you guys like this talk and would welcome me back, I will prepare another talk that will build on top of this one that will actually take you guys down the path of creating native UI components. Does that sound good? Awesome. Okay, so let's take a 10,000-foot perspective of React Native. React Native intrinsically is just a library, okay? It is a suite. It is a suite of technologies ultimately, but it's I like to think of it as just a library. It is. Sorry, I just want to trip myself up. the whole purpose of React Native in general is just to bind your JSX code to native controls. That's what it lives for. So if you think about things like in Cocoa Touch, okay, so you have these awesome transitions with the applications that you leverage today. You can render text, you can render views. React Native just basically allows you to write some JSX, and it creates implementations or instances of native custom components. Sometimes the Facebook team has done a good job of, or generally, the Facebook team has done a good job of wrapping out-of-the-box components, but it allows you to go well above and beyond that. React Native itself actually has its own custom layout system. Who here absolutely loves CSS? Wow, you guys must be masochists. So with the invention of React Native, the team decided, I think it was Christopher Shadou. I suck at French, so apologies, Christopher, if you're watching this. He thought to himself, let's go ahead and build CSS from scratch. What would the web be like if we didn't have a big pile of shit that is CSS? No offense. What would life be like? And what he came up with was the custom layout system. And he thought, well, shit, we could live with just two different types of layouts. We have Flexbox, which can lay things either in a column or in a row, and we have absolute layout. Turns out, to develop React Native applications, it's really simple. He actually also distilled the best of CSS into this custom layout system, and he calls it CSS. It is not CSS tradition like you think of it, but it is so much easier to use. React Native itself leverages a suite of technologies. Anything from the Babel transpiler to a special packager to a custom implementation of the CommonJS pattern. React Native is a big pile of stuff. If done right, your React Native applications can run at near full speed. Now, some people have said, well, it runs at full speed. It does not run at full speed. Now, they try their best, okay? They try to get you 60 frames per second. That's what the run works its ass off to do. But the reality is that as your application starts to grow and it gets more complex, a lot of that logic is inside of JavaScript. And while JavaScript engines are fast, they are also still interpreted. So you have to think about writing efficient JavaScript, and not to mention leveraging the best of JSX or React.js to make your components as fast as possible. I've been working with this for almost a year now, and I've said this since the beginning. I still see it this way. The architecture for React Native is extremely scalable. You could do things like import an existing web application and model it in a web view and connect your React.js web application with your React Native application if you want to do that. You can take your React Native application, because it is a library, and include it inside your existing iOS application. There's so many different patterns to leverage this. It's amazing. And the library itself is extensible. There are some pains when it comes to extending the library. So the design patterns that they've created kind of pigeonhole you into sometimes copying and pasting code, which is not the best pattern, but it is what it is. So I'll give you an example. I wanted to extend the map view implementation. And in my application, I wanted to know when people were zooming and manipulating the map, how many pins were actually visible on the map. The React Native application doesn't give that to you. Excuse me, the React Native library doesn't give that to you. So I thought to myself, well, let me go ahead and extend the RCT map view, which extends or implements the MK map view, and I just add the features I want. Turns out I actually had to copy code from the map view manager, the map view class itself, and the wrapping JavaScript to inject my features. And that bit me in the ass at least 4 releases in a row. But it is what it is. And I would still stay with React Native even with this pain to date. So I've had some people say, well, React Native uses JavaScript. It's got to be hybrid. No, it's not exactly correct. Hybrid, we think about having a native container or wrapper leveraging HTML5 as the UI layer. React Native is not that. React Native uses JavaScript to control native UI components. So why use React Native? Well, if you want a native feel to an application using existing JavaScript skills, React Native makes a lot of sense. If you don't want to master Objective-C and have to also master Cocoa Touch and all the shit that includes is included with developing applications for the iPhone or Android, as Stan will talk about, then React Native makes a lot of sense. I've read some articles where there have been some companies who have decided to experiment for a few months and develop React Native applications, and what they found is that they could leverage their existing iOS team in conjunction with their web team to develop awesome performing applications. That's pretty goddamn powerful. I believe React Native gets us much closer to the write once, deploy many, which has been the promise of HTML5, mobile HTML5, since 2011. There are some pains with that, and Stan will walk you through some of the awesomeness that is the Android implementation. But the reality is that once you get over these hurdles, the net is that you will end up with a better performing application with a better user experience, which is all what we want for the mobile space. So as I said, there's going to be pain, and there has been much alcohol involved with some of my evenings. So just be prepared when you go down this path. It's not just, all roses and it's just going to be, oh, you write some JavaScript and your application works. And then, no, you're going to run into some walls. But the good thing is the community is there to help you go beyond those hurdles. And sometimes you just need mad skills. This is important because as you go down the path of writing custom modules, that's where you start to have to learn Objective-C or Swift or Java for Android, and Google becomes your friend. So skill sets to build React Native applications includes JavaScript with knowledge of React.js and JSX, ES6, which is just recently got ratified a few months ago by the ECMA group. You have to be naturally familiar with the Chrome and Safari debuggers and the common JS patterns. So yes? So
does that mean we don't have to use Vowel anymore? Or? I
think it uses it by default. Yes. It wasn't the case many months ago, but they switched over to it, I think. Shit, I was going to say something about the JavaScript side. Thanks for derailing me.
I'm the worst.
No, I'm trying to think. I was just like, I had something that I wanted to describe on that space. So what's awesome about React Native also is that, and I will show this to you in a demo, your workflow for developing React Native applications is really similar to developing web applications. And I found this to be very, very powerful. When I first started with React Native, the debugger extensions were not complete. And I had to resort to, anybody remember what life was like before debuggers in the web? Yes, what was it like? What did you have to use?
Whatever you could.
Alerts. Yes, I had to use alerts. And I actually had console.logs. And it was interesting because once they enabled the Chrome extension, I don't know who would choose to use Safari debugger with Chrome. Wow, okay. Safari debugger gods are angry. But I remember when, okay. Get louder. Kick their ass, Andrew. Erica's gonna kick their ass now. Stop it! I told you I'm done. So when they released the Chrome debuggers, I remember thinking, wow, this was like when Firebug was first released. And it was an amazing moment. You have to have some knowledge. She slipped it, bro. She totally went in. So you have to have some knowledge of the React Native built-ins that will come to, as you start working on things. For example, what components are available, what native modules do you have access to, geolocation, alerts, and so on, the custom layout system, and CSS. You don't have to be a Node developer, but you do have to have Node installed and have familiarity with NPM, because you're going to be installing modules left and right. In fact, NPM is actually, oh shit. So NPM is actually how custom modules are shared in the community, which is fantastic. So the common convention is to prefix custom components with React-native. So if you want to search for anything React Native, just go to npmjs.org, search for whatever you're looking for. Fantastic resource. If you're extending beyond the out-of-the-box built-ins, then naturally you have to learn C or Notes, have some familiarity with C, Objective-C, and or Swift. Oh, this is fun. And you also have to be familiar with Xcode. And naturally, if you're going to extend UI components, Peppo Touch. With Android, because Java, C, an Android-leading IDE, I know there's so many out there, the Android SDK tools, and the awesome CLI dev tools. So, wait a minute. Okay, so there are a few ways to extend React Native, 3 patterns that I've found. The first way is using JavaScript entirely to extend components. And in fact, this was something that I found out my first month in the community. And the idea is that you just wrap JavaScript, or the JSX components that come out of the box, throw some JavaScript logic around it, and you have a custom component. And the second dimension to that ES6 pure JavaScript component extension is going to be a utility. One of the things I've used in the recent past was a font packager thing, where if you want a bunch of custom icons, you just install this NPM module and you use this custom little icon thing, and no Objective-C was written, which is fantastic. This this little screenshot that you see is a snippet of the React Native parallax view that was written and released. And what's awesome about it is it gives you this awesome springy effect when you move things up and down, and it gives you this cool parallax view. And I fell in love with this pattern and decided to use it in an application that I'm working on. And I, went to see how they did it, and I was like, holy shit, it's completely JavaScript. That's pretty freaking powerful. Another way to extend React Native is to expose native APIs. So for example, I've written a custom sound driver using Objective-C and exposed the methods to React Native. I've also done things like wrote my own custom SQLite wrapper and some file system utilities. And what I also realized is like anything native from a non-UI perspective is going to be this pattern. So the last dimension or way that you can think of this extending React Native is using developing custom UI components. There is an OpenGL filter for your React Native applications that leverages OpenGL for iOS. I don't think it has been released yet for Android. But for me, I decided to experiment using something called Easy Audio Plot, which leverages OpenGL, takes audio FFT data, and renders it on screen when playing. This guy is a custom web view. This is an audio player that I released. This view wasn't released, but this shows pattern data that is being used by an old Amiga module format called a mod format. And so as the audio played, the positions updated, and I wrote a minimalistic web application. So this, what you're seeing moving, is actually a web view. So I started to experiment with WK Web View, and it turns out implementing this was not difficult at all. So I exposed my custom WK Web View and then gave it a very minimalistic, not even using jQuery, just pure JavaScript. I injected, when this view was loaded, the pattern data, it rendered divs and so on, and then the events driven or emitted by the sound driver were being received, and that's when you see the patterns being moved and updated accordingly. This is an implementation using the exact same application and experiment. This view I plan on releasing into the App Store soon. This is leveraging the Easy Audio Plot. And this does not shuttle data between the Objective-C to JSX to get you 60 frames per second. I had to kind of go around and have this Objective-C view connect directly to the sound driver. managed by JSX, because what I found is that if you overwhelm the run loop, then your UI will be non-responsive. And what happens? Your application's just a bed. And then this is a WK WebView implementation using Three.js. And those flickers that you see of green are actually data being emitted by audio. And whenever a certain note on a certain channel was received, it flickered green. But the idea was, let's see if we can even do something crazy like use WebGL using an abstraction like Three.js, and then connect that to an audio driver and see what type of performance we got. And this is running in a simulator. I had this running on my iPhone 6 without any problems. It was fantastically fast. So from a 10,000-foot view, React Native is relatively simple, right? You write some JavaScript, it connects to some native controls and some native APIs, and connects to your phone app, right? And at that point, it's magic. But React Native is not magic, okay? As you start to dive into the innards, if you are an Objective-C person and really like to figure, or just curious and intrinsically curious, as you start to dive into the source code, it actually does feel a little bit like this. I'm hoping the Facebook team, if they see this, don't get offended, but I'm not going to bullshit you. Some of the code is not well documented, so my notes look more like this also, because there you have shit connecting to things, and you have asynchronous loops and all types of crazy things that you really have to get your mind right to dive into the React Native. So I'm going to walk you through three demos from the Objective-C side that I wrote, creating a custom module. Can you guys see this back there, or is this too small? You good? All right. Okay, so here I have Xcode, and in my application, what I did was to create this demo is I just created a Hello World basic scaffolding application, and I wanted to walk you guys what it's like to define a custom module. So it begins with your header file, and this is where you have to import the RCT bridge module, that H header file. That gives you things like some of your event handling and so on. And it's leveraged inside the RCT bridge protocol. And for this demonstration purpose, there's nothing else that is required in the header. So in my custom module, this is where things start to get a little bit more complicated. Who here is not an Objective-C person or Objective-C programmer? Good, because I'm going to explain things really slowly. Because from JavaScript to Objective-C, it's a bitch. Okay, I'm not gonna lie. Like learning Objective-C, I remember I was sometimes in bed late at night, like trying to figure this shit out. Many books, many beers later. Yes.
Just a stupid question.
No stupid question.
Skip the Objective-C, just learn Swift instead.
Because 99% of the library is written in Objective-C. Objective-C has existed since about 1994 and will continue to exist probably for the next 10 years. So Facebook favors Objective-C for a myriad of reasons. So for me, learning Objective-C, when I started learning Objective-C, Swift was just being discussed. Well, was it Steve Jobs? I think was the first person to announce it to the world, and it was very unstable. And so I focused on Objective-C. So if you want to learn Swift, great, but there are times where, even on their examples, when you want to write Swift, you have to write Objective-C methods and annotate them accordingly.
It's a little suicidal.
Using Objective-C or using Swift?
No, Swift.
Correct. It's funny because like I've seen people, I've talked to people who have love-hate relationships. There are some people who are complete evangelists and they'll bear the Swift cross and get.
Well, you want, if you're stupid enough to want to have a life, you want a simple one. Just tell me one piece of software, and it just doesn't work like that.
Awesome. I'll keep that in mind when I start to learn Swift in 2016. All right. So you have to require a bunch of. So when you import a header file, importing a header file basically is importing definitions for classes that you're going to use. So I have to import this. These things have to be in your custom module. Okay, I'm not going to go through every one because we're going to spend some time in the actual methods themselves. But the important thing here that I'm going to show you is that when I define synthesize this bridge, it's going to give me the capability to emit events, which is what we're going to do. So the first thing I'm going to show you is what it's like to expose a method to JavaScript. And that's what this guy does. This is called a macro. So this macro basically is a preprocessor directive that allows some code to execute before your code's compiled. And what he does is massage this method definition that I'm highlighting right here and wraps some React Native stuff in it. For lack of a better term, I'm not going to go too crazy diving in, but that allows us to expose it to JavaScript. And the implementation of this custom module class, getRandomNumber method, looks like that. Okay? So in my JavaScript, I can actually execute custom module.getRandomNumber. So let me take a step back and let's look at the actual definition. So the method signature or name is getRandomNumber. It takes an argument, which is an instance of an RCT response sender block. In Objective-C, even in Java sometimes, names can get very long. But this RCT response sender block actually is, think of it like an actual callback reference that you get in JavaScript. It works very similarly. So when I invoke that in JavaScript, I actually pass it a callback method. This is called an ES6 arrow function. Okay? ES6 arrow functions are awesome. Oh, sorry, who doesn't know what an ES6 arrow function is? Good. Okay. So I pass in my callback, and there is mapping that occurs in the bridge, which is what connects your Objective-C or Java to your JavaScript. So there's indexes and IDs and all types of crazy shit, but the idea is that in my Objective-C, I'm going to generate a random number, and I'm going to emit that to JavaScript. So in my success handler, I have an argument called random number. And all I'm going to do is just alert that, okay? And just to show you what that looks like in Objective-C side, I'm going to put a breakpoint here, tap this, if I mouse over, we see it's an integer value of 37, okay? So, on the JavaScript side, I should see an alert that says random number is 37. So I'm going to click resume, and there we go. We have our alert dialog. Now this is hardly anything that you would typically do in the in real applications, but it actually does show you what it's like to actually leverage a module. One thing I forgot to expose to you guys is actually how to include that. And this line, item 16. So I have a local lexical reference called custom module, which is the result of require the React Native modules, its custom module property. So once I have that custom module reference, I can leverage it however I'd like. So again, the getRandomNumber method is invoked when I tap that text. And that's done through what's called a touchable opacity. For those of you who are used to the JSX world, a lot of this may look familiar, but not entirely, right? Because you don't see divs, spans, li, ol, ul, all that shit. What you see is like these weird, unfamiliar components. These are the React Native components that are mapped to JSX that actually create custom UI components. So touchable opacity is a custom class. It's a wrapper that extends view ultimately, and its responsibility is to listen for press events, and if I press and hold it, it dims. Now you can configure the opacity value on shit. So the idea is that I can configure a property called onPress, and that calls the onGetRandomNumberPress, which executes my custom module's getRandomNumber method. That generates a random number in Objective-C, shuttles it up to JavaScript. Now, modules can fire custom events as well. So here, I'm exposing to, yes?
What kind of data can you pass from your native to
Primitive types like NS string, NS array, NS dictionary, NS number, NS date.
If you pass them the integer, it'll auto converts what they're coming to. The integer times that.
But like, nothing like, not like structured data or anything like that.
We mean structured data.
Objects.
Yeah, NS dictionary. That's a key value pair. Yeah, so you have to be very careful how you create the responses. But I'll give you an example. In my SQLite driver, I'll have a string that I'll say, give me all events in the state of Alabama. And it'll do the query and respond back with an array of dictionaries, which are key value pairs that came from SQLite. And it's pretty fast, but like I said, don't want to engage in too much of a rapid loop because your event loop gets screwed up. If it gets overwhelmed, there's no throttling mechanism that can prevent you from stepping on your own feet. And you won't be able to touch the UI anymore. It just locks up and yeah. I did that by accident, actually, when I was working on this, because I'm a noob. I'm not really, I'm just playing. So you have the capability of firing custom events as well. So custom events, think about geolocation. So let's say in your application, when the user's walking around the city, you want to be able to listen to GPS points. Well, how you do that is you would listen to events. You would have a listener set up in Objective-C, and it would emit device events. Okay, so in trying to think which direction should we go here. Okay, to register a device event listener, it's as simple as executing the add listener method of the RCT, short for React, device event emitter. Okay, so RCT device event emitter.addListener. You pass in the event name and then the callback. And then forever for the life of your application until you actually remove the listener, it will call that method. Okay? So in the Objective-C land, what I'm doing is I'm actually exposing a method called fireCustomEvent. This guy takes an NS string as an argument with event name. And in my JavaScript, I'm actually going to execute custom module.fireEvent, and I'm actually going to ask it to emit an event so we can do a round trip. In addition to that, I'm going to generate a random number, because in the real world, that's all we do, right? No, we don't. Okay, so in order to emit the event, I ask the event bridge. So it's _bridge.eventDispatcher, execute its send device event with name method, passing the actual event name, which is, by the way, let's pass the argument, and then an event body, which is an NS dictionary, key value pair. Somewhat structured data, not very detailed, not very deep, but it is structured data. So when the component mounts, I register these events. So if I fire an event with event space 1 or event space 2, the on event received method would be called, and he does an alert that says, hey, I've received this event. Oh, and by the way, this is what random number it was. So if I press that, we see the event 1 was received. I do it again. Random number is different. So it's not black magic. It's all computer programming.
Was that all?
I'm sorry? Yeah, that's what. Just throw some code on there, just like they do in the movies, right? It's like a warning. Sorry. You ever notice, like in computer movies, there's like, where whenever you see a computer on screen, there's like all types of beeps and bloops and shit. I would want to punch my screen if I had that shit. I'm so glad they got away, or they did away with boot up sounds. Remember that? It was a big thing like many years ago. Your computer is already on, thank you. So let's talk about backgrounding. So one of the things that your modules can do is they can execute code in the background. And this becomes very important because part of the whole, the DNA of React Native is that things run asynchronously. When you actually execute an event or you dispatch an event, it actually runs in an asynchronous fashion. So one of the things that you can do, imagine trying to insert, I don't know, you download a zip file for your application, it wakes up, it says, asks the web server, hey, do do you have any updates for me? The web server sends back 3 megabytes of, unzipped SQL data that needs to be injected into a local SQL database. All this shit you initiated through your JavaScript queue or thread. If you were to try to do that in your JavaScript thread, your UI would become unresponsive. So the idea is that you would want to do some things in the background. To simulate a long background task, I simply do a sleep. That's not right. I'll leave it there for now. So in order to execute a background thread using something called global GCD, Global Dispatch Central? GCD.
Grand Central Dispatch.
Grand Central Dispatch, thank you. I'm asynchronously executing a block of code using GCD and just say, execute something in the background. Now, what's awesome about this is the success callback, which is the response sender block, is being passed here. So I execute custom module.bgmeth. The method names started to get really long when I was doing this, so I was like, I'll just do it really quickly. So we have a counter that gets updated. There's this little block of text, which, let me fix this, because I realize that that is tiny. Fantastic, okay. I know that. So when I do something in the background, the counter will execute. So basically we have 2 asynchronous paths of execution that's going on. And when the background process is done, the counter stops. And the important bit here is that in order to execute something in the background, we could do something like we can set up a P thread or a custom NS thread if we want to do that. But I'm using the best practice that they suggested, was using Grand Central Dispatch. And what he does is just basically do a wait. And if I were to pull this up, it's hard to see, but let me clear the console. You will see the weights being displayed up there. So as one side is updating, the other side is updating as well, and we see something going in the background. So you could go above and beyond this, like I said, anything native that you want to expose that's not UI, you would create a custom module for. Any questions on what I showed thus far? Yes?
I'm wondering, PHP and HTML will be combined, or similar programs like that, if JavaScript and Objective-C are combined in the same way like JSX and the double curly braces combined, that sort of thing? Or is it just you create your web component, your UI components in C separately, and then?
Okay, yeah. So when you write your JavaScript, it is exposed in dev mode through this packager. This is a Node application that's running in the background.
Okay.
And what's cool, let me show this to you. That's not what I wanted to show you. I know what I'll do. Let's go back to Xcode and open there's a URL. So when your application starts, there's a string called JS code location.
Mm-hmm.
And for dev mode, it is a URL that is only openable, or I guess leverageable, when your app is in dev mode. But this basically is the JavaScript that gets ingested. Okay, so this gets, it's a lot, it is. Because it's React Native, it's the JSX interpreter, or transformer, React.js, the React Native library that implements JSX to React Native, all the module shit, and your application code. So it can get pretty good. It's minified when you go to production, but there is no web component, anything other than that for developing mode.
Okay.
And when your application is bundled for production, it's labeled red here because I haven't created it, but your JavaScript is bundled. It's a JS bundle just basically means a minified JavaScript file. And then that's actually shipped right now with your native applications.
The second question is, shit.
I don't shit. No. The train left the station.
No, look back.
I hate when that happens.
Right ones deploy everywhere.
Yes.
If you have touch components and possible Android components and JSX normal HTML DOM components, is that really going to work, or do you have to do they coexist in the same?
No, so
So you have touch opacity. If you just have normal divs in the same library that,
It won't work. No, there has to be so there is something which I don't agree with this project altogether, because going to React Native means you ditch the bullshit from the web.
Right.
But the deploy once, write once, deploy many dream is so strong with some people, and no offense to the people who developed this, I just don't agree with the project. There's something called React Native for web. So it actually, you can write React Native code that gets deployed on the web.
Sure.
So it transforms your views and text components to divs, and it's just like why?
okay,
You have something that's so fast, why would you ever go to something that's not as fast?
Mhm.
But they want to be able to have one code base, so they have abstractions with abstractions and a little bit of extraction on the side, it gets ridiculous. But no, your JSX that you write today for React Native is yes, it's only for React Native. One thing I'll show you is this is what the CSS looks like. This is just a small slice. Just JSON.
and that's the custom native version that you're talking about?
Yes, the React Native CSS. This is what React Native CSS looks like. That's orders of magnitude easier for me to read than CSS. And again, I've always been not a fan of CSS altogether. But I mean, if you're a CSS person, I mean, this shit should make some sense, right? So the question is, what are these keys? Well, these are just pointers or references to an object, which basically becomes a style sheet. And oh my God, look at this. Styles.touchable containment. Done. Or I can write them in line, like you see down here where I'm setting font size. I can do something like border width 1. Shit.
No, we're not checked, right? You're not,
Say again?
don't you need to pass in a
Oh, no, you can't pass border width on text. God damn it. Sorry. I see. Trying to think.
Change the color.
Color.
Oh, there you go. No, wait a minute. Get current app state. Oh, this is something else. I have no idea what's going on here. That's weird. It's not working. I have no idea why that's happening. Let me see.
By changing font size.
Yeah. No, something's definitely wrong here.
I think a package might be.
Yeah, did it ship to bed? No. Weird.
You bought it?
Yeah, I'm gonna close everything. Like I said, there will be pain. It happens. Disable Chrome, disable Live Reload.
Are Facebook and Instagram the apps written in this?
Facebook, no.
Parts of.
Their groups app is native.
React Native, yes.
Messenger?
No, I don't know about Messenger. I know that the Ads Manager.
Okay,
And supposedly there's parts of the main app that are React Native.
right, okay.
So, let me see this real quick. Stan, how do I get to the device? Is it recording? New? I want to show my phone.
Yeah, new video recording.
Movie? Yeah.
Yeah.
And then,
And on the arrow, you click there.
hey, look at that door. Why don't I see my word turd? There we go. I forgot to name my phone now. Oh, it didn't like that. There we go.
Correct?
Hey, shit the bed. Let's try that one time.
Get your laptop out.
No, I don't want to do that. Okay, there we go. So I'm going to show you an application that I think is freaking awesome. So the Discover VR project or app is written with React Native. Now you see some of that jerky nation, I guess, dropped some frames just a few seconds ago. You can see it here. That is a clear indication that they're leveraging React Native. Because this version of React Native, when the images render, it blocks. So this wasn't fully optimized. But this is pretty damn awesome. Let's see. It has a device event emitter for me to move around, flip this way, and I can be like, hey, there's a shark or some shit. Don't get eaten. Complete 360-degree video. And hey, there's the asshole at the camera. Okay, I'm kidding, of course. But how awesome is that? And I can use the Google Cardboard or whatever. Pretty awesome. This is one of my favorite demoable React Native applications because it, from many perspectives, is pretty damn awesome. I think with some optimizations that this can be even better. But it'd be hard to tell that there's JavaScript, running things behind the scene.
Can I ask another question?
Yes, you can.
Well, like when 5 comes out or 15, will that have automatic optimizations
When what comes out?
when the next version reacts or whatever it's version at?
69.
Oh, okay. Will that be automatic or do you have to like
No,
rebuild it? Because I know that it kind of moves pretty quickly.
they like my oh shit tweet, that's awesome. No, so one of the things about JSX, my understanding with core DNA or core tenants is that, or React.js, I keep using React.js and JSX interchangeably, but they're not, is that optimizations are left up to you. And that's actually one of the first things that they told me. So remember that pattern view I was showing I was animating? Where is it? This guy. No, there we go. This guy, okay? This guy I showed you guys. Now I said to you that this is a custom HTML5 view, and it completely is. And the reason I decided to mess with the HTML5 view is because I actually had an issue with React Native. And assuming Wi-Fi will cooperate, wait. I'm gonna put it here. There we go. So I actually had performance issues, which blew my mind. Ignore the sound. Okay, how do I turn this off?
That's what it was.
Okay, left side is React Native, right side is Ascension Touch applications. And if you notice on the left side, it actually pauses during the page split. Exact same phone, 2 different video instances taken. And this is where I had actually was told by the React Native team, performance optimization is up to you. And this is before I learned about component will receive props and preventing the rerendering of items. So no, there is no automatic, we're going to fix your application. But from my understanding, they are working on performance issues altogether. I mean, Stan, we talked about this evening. They actually have an entire team that was dedicated just to performance, which is amazing. That makes me super fucking excited. So I showed you what it's like to use the bridge from a 5,000 foot perspective, using your JavaScript and then the Objective-C. When thinking about custom UI components, you basically take what you know from the module side and you extend that knowledge, and what you do is you leverage what's called view managers. So this actually is, what happens, how the connections are built. So you create, as you saw, view, touch opacity. There are some other items I have up here, like scroll view, slider, tab bar. Well, your JSX basically are bound to managers. They're like view controllers. And from there, your view controller controls your actual views. So when you do things like set props on a view here in the JSX side, that actually talks to the manager through the bridge then using the React tag connects to the actual view instance and modifies it accordingly. So this is what we'll be talking about, assuming you guys will allow me to talk again over here. Next time. So some good places to learn about this stuff. Facebook, React, documentation. They link off of their Facebook, GitHub page. They talk about how to deal with native modules and then native UI components. But the documentation, in my opinion, is good. As always, documentation could be better. But one thing I'll tell you is, in closing, is that there's a lot of source code reading, and not a lot of documentation for a lot of the native components. But it's a good learning experience, in my opinion, because some of the design patterns that these guys leverage, I can tell you, are top-notch. Coming from the Cordova world and having to write custom components for Cordova, I'd rather write custom components for React Native all day, every day. I'm so happy to mentally have ditched Cordova for my mind. So that's pretty much what I have. Thank you, guys. Yes, questions?
What would actually just do native instead of?
So native will give you the best performance, but the reality is that doing native work is actually harder. You're going to be doing, you typically would do a lot more work on the native side. I could work on UI components way faster here, me personally. With my JavaScript knowledge, I would have to learn the barrier of touch, the whole MVC architecture, maybe even data. I mean, there's all types of things that you have to think about when learning native UI components. Then I gotta take that knowledge and now I gotta transcend that shit over to the Java side and learn Android UI, and it just gets out of control. A lot of that's the abstraction is there for you to leverage to increase the speed of your delivery. Because it's a trade-off.
Performance-wise, they're very close. So,
Do what?
I mean, performance-wise, both implementations are very close.
I would say that if you do it right, native is going to outperform this. Just like I showed you with the VR app, like you are noticing some glitches because the images are blocking the scrolling in the thread. In native, you would use like async kit or something. Have it did. So you wouldn't see that in a well-written native application. With React Native, getting around that gets to be a lot harder. So there's a price you pay for the abstraction. But I've had people ask me that. I've been doing talks since February about this, and the reality is that native is going to net you the best performance always, but the barrier is a lot higher for a lot of people. Any other questions? Yes.
So would you be able to tap into a lot of the modules and NPM as well? Like, let's just say I'm a newbie at this, and
Yeah.
I want to say, would I be able to use something like Webpack in my own React Native app, or no?
To be honest, I've seen talk about Webpack, but I have not used it.
Okay.
You'd be able to do stuff like Moment, anything that doesn't require DOM.
Yeah. Those types of utilities, yeah.
Okay, so you wouldn't be able to use everything.
Right.
Just the stuff that's not even DOM related.
All right, so Stan's going to jump on and talk to you guys from the Android perspective. So you guys want a beer while he gets set up? Feel free to.
Very good.
Yeah, sure. So does that talk too nerdy for you guys?
Well, that was good. I sort of presumed, I don't know if anybody else did, but it was like literally write once, deploy anywhere, that it would do the web version of what you talked
I see what you're
about.
saying.
Where it's like you have to touch a page or something,
Yeah.
and it would do Android, web, and iOS,
No,
and Windows.
Well, that was promising sound.
Yeah, so it's just, so the funny thing is, it's just iOS, Android,
Yeah,
and someone actually wrote like a side fork that does React Native OS 10,
yeah,
and then another side fork that does React Native for tvOS.
okay,
So it's like, there's so much shit that you can use this for.
right.
Except for Windows Phone, Firefox OS, you know, all the other things that are not Android, not
Right,
that.
Yeah.
But that's all possible.
Yeah.
You can add those platforms on. It's relatively straightforward.
Right.
I'll talk a little bit. I think I see what's up with that. I'll cover a little bit of it, yeah.
All right, good. Is that water over there or beer?
Water.
Here.
All right, I guess we'll get started. Hi, everyone. My name is Stan Bishatsky. I'm going to talk a little bit about React Native for Android. Before I get started, how many of you guys have done native Android development? Just one, two? Sorry, I feel so bad. I feel so bad. I'm sorry. I'm not a native Android developer, but I've done plenty of Java before. Then I stopped altogether. And then when I had to pick this up, it's like, all right, let's shake all the cobwebs a bit. And then I realized, holy shit, it's not fun at all. I have done native iOS. And this was something else altogether. Every time I'd be working on something for React Native and Android, something Android specific that would require actual Java work, I'd be messaging Jake, just cursing randomly. But yeah, so today we're going to talk a little bit about how the Facebook team built React Native, the Android stuff, the Android part of it, how it actually came together. I'm not going to get into too deep because that's a whole separate talk. And I'm going to talk about a story of how I took a React Native app that I built originally for the iPhone, and when the Android functionality came out, how I migrated the app over to the Android stuff. And that's a common thing where you develop usually a year after the iPhone first or iOS because the experience there is much better. Sorry to any in the Android fans, but and then you move it over to Android because you have to support the rest of the market share. And that includes native modules, which is the highlight of the talk. So let's talk a little bit about React Native for Android. Sorry for my Photoshop. So what can we do with React Native now? Again, as Jay mentioned earlier, the whole big thing with HTML5, only HTML5, write once, run anywhere. Facebook's like, I don't want to give you that. I'm not going to give you this one-shot solution. I don't care if you have the same code everywhere. What we want is for you to be able to build really nice applications for these different platforms. And we want to give you the tools to use the same tool, but you get a really fluid user experience that's platform specific. So they don't want your iOS app to look like an Android app, and vice versa. They want you to leverage those native components, which you will. That's the whole point is. So, for example, in native Android UI component will have stuff from Material Design already. It'll have ripple effect. It'll have just the way when you tap the font, all that stuff. When you build like a mobile app, or hybrid, like a mobile web app, you actually have to style all that stuff with CSS. There's no way to say, oh, I want a native, unless you use like pickers or alerts, which are the native. But here we're building, all our UI components are the native components. Our lists are a native scroll view for iOS, or I forget what this scroll manager for the Android is. And the second part is you could migrate your existing iOS apps, which is what Facebook did, because React Native iOS came first, and that was like that's their golden child. That's the style. That's like that's where they put all the real effort in, and then they took that and built the Android functionality from it, and you could actually tell from when you start looking under the hood. That's the mantra that they followed. So some things you get from being on Android is you get the drawer layout, which is the site navigation. Obviously, this is not styled, but under the hood, you are using the Android UI drawer layout. So that's you can do your hamburger menus or whatnot with that. Sorry, you get the native progress bars. This is a screen recording, so obviously it's going to be much more fluid. So whatever frames per second is supposed to render at. Just the native switch, just these basic components, toolbars, the hardware back button support, toast, Google notifications. You get all that. That's all native, and that's all Android only. You're not going to be able to use these things on an iOS device. There might be equivalent iOS versions like Switch. If you use the Switch component, if you do it in an iPhone or an iPad or whatever, any iOS device is going to render the iOS Switch. If you have the Switch tag and you do it in Android, it'll render the Android one. And then, so the existing modules, so like list view, those all stay the same, and then they have underlying implementations that are platform specific. But because they are platform specific and they use, again, those native components, you'll get those Material Design interactions on Android. You get the over scroll where you drag and it just pulls lower. That's not going to be implemented in JavaScript, or if you're in the browser world using WebKit Touch Overflow. It's not doing that. Native. Pull to refresh, stuff like that. So how does it all work? That's the big thing here. So the JSX stuff is mostly the same, JavaScript, between the applications. Yes, there will be a few differences. You could get them pretty close between the platforms to be complete. And then everything here is where I call the magic of the React Native Android. So this is all the React Native stuff. I'm going to start with the Android indicate, which takes your Java. So your JavaScript goes to C++, and then goes to Java. It's not a pure JavaScript to Java bridge. There's a C++ in the middle, and what the C++ stuff does is it invokes a thing called JavaScript core. Who's familiar with WebKit, the rendering engine? JavaScript core is WebKit's JavaScript engine. Now, Android does not use, Android uses, I think, Blink now because they use the latest Chrome. What React Native does is it packages JavaScript core inside of it. Not the whole WebKit, that's like, God knows how many megabytes, but it takes JavaScript core. And the reason for this is for a consistent interpretation of that JavaScript to C or C++. So this way they could guarantee that whatever JavaScript I pass in, I know what results I'm going to get when it gets interpreted through JavaScript core. And then the last step is translating it into my UI layer, which is Android in this case. It could be anything else. It could, as long as you have these two components, you could then write your transformer to whatever native platform you want to do, BlackBerry, Windows Phone, whatever you want. So that's their whole gimmick. Now, what actually happens is the translations are done for iOS. So you'll see, like what Jay mentioned, RCT map view, RCT text, RCT view. And then there will be there's a module registry that translates it to the Android specific implementation. And that will go to switch Android, scroll view, Android. So it'll go iOS translation, and then I'll look into a registry and pull the Android or whatever platform specific translation there is. This is how you bootstrap an Android application. You have this is your main activity. Activities are like the application endpoint, start points, you could say. And we instantiate the React group view, which is just a view group. We have to set the module name. This is the file, the index.js. So there's an index.ios.js and there's an index.android.js. You could have it just go to index.js and then in your JavaScript have a platform-specific code. But at least for the starting point, it's generally recommended to have start that branch. Then the important part is this add package. As you build your Android React Native Android application, you'll be adding packages. You could either extend the main React package into your own packages, which is what I did, to add your own custom ones, or you could keep adding packages, which are wrappers for your native modules. So that, I'm going to focus a little bit on that main React package. It holds three things: your view managers, so that's your native UI views, so that's your scroll views, list views, switches, everything that's built into React Native. And whatever other custom UI components you want to add that are already not part of it, but let's say you have the native Java, and these are just pure view components that you're going to use inside your JSX. Those are your view managers, and your native modules are your the code that you'll execute through your API, through like Android specific API, so like your calendar API, Toast, that's a native module. And JS modules are just utility classes that you expose in your JavaScript. They don't have to be anything API related. That could be like your URL connection, like setting up a URL connection. That's a JS module. So, and this is how the views are actually implemented when you do have a custom view. It's pretty straightforward. They use the Android UI, the SDK UI, and all they do is they instantiate it just like you would in an Android application, and then you return that view, and then React Native already knows where to put it in through its messaging. So, for example, the progress bar, it's called the React. This is the React progress bar view manager. That's the actual class, but all it does is instantiate the Android.ui, whatever it was, Android progress bar. So under the hood, it's all native Android components, and all you're really doing is passing arguments back and forth. So let's put on our developer hats, and first I'm going to start off with some quick tips. If you want to use Android Studio, which is the default Android ID, if you pull the SDK, it comes with Android Studio. I like it because it wraps IDEA, IntelliJ, or JetBrains' product suite. So I'm pretty comfortable with those because I use WebStorm for my JavaScript development. I would recommend running React Native Start in your terminal or wherever you want separately, that, especially if you want to develop both iOS and Android at the same time, because React, the IDE, Xcode will kick off the packager when you hit run, but React, the Android Studio won't, unless they change that recently. So I just know to start off in the terminal separately, and you won't have to worry about it might not be running, then you're gonna start getting errors, oh, I can't find your JavaScript. So the way the React Native packager knows what code to run is two ways. Either it'll start looking for, when you require a file, it'll look if there's a .android or .ios file, and based on the platform you're running from, it'll pick those. Or if there is none and it's just a .js, it'll go on both platforms. And then if you ever have any platform-specific code, there's a platform OS property, and that returns a string Android or iOS. It's not like a constant, or you just do a string comparison. For the iOS developers, we're used to Command D for the developer tools. Here it's F2, and Command R doesn't work. You actually have to go F2 and refresh. Unless you're using Genymotion, or Genymotion, I'm not sure how to pronounce it. That's the different Android emulator. I'm not familiar with it. I'm using the officially free one, and I can use Genymotion for free, but it's not like for commercial. It's like personal use. But yeah. So this is a simple React Native app that I built for myself. My gym has a website, and they put their schedule on, and it's like an iframe that's served from like an ASP page, and on the mobile device you can't read against it. So I got too frustrated. It takes like 15 seconds just to open their page. So I'm like, I need to know what my gym schedule is. So I'm like, all right, let me see how they're getting their data. I found out they call it an API, but it's really an ASP page that renders tables, like HTML tables. Oh crap! All right, let me parse it out and put it in my React Native app. So I used, if anyone's familiar with Cheerio, it's a module on NPM. It's like a headless jQuery, that's what they call it, even though it doesn't have all the selectors that jQuery does. So it's still a little troublesome. But anyway, you're relatively easily able to parse DOM and just pull data out of it. So I did all that to give myself some structured data, and then I put that into my React Native app, so I get a much faster experience. I haven't shown this to the gym just because I don't really want any issues with it, but it does help me a lot. So there's two really main components in the application, and as you can see, there's one side is iOS and the other side is Android. I made them look pretty similar, but because of using the different components, I get some benefits of the interactions, as like the font's a little different, and I'll show you some of the ripple effects. But the list view with section headers, so that becomes the native component. And then I have a calendar native module. So that's to add, when I tap a row, I want it to add to my calendar. Just a reminder for myself. So obviously the iOS implementation is going to be different than the Android implementation. And the goal I had was, I'm okay with the implementation being different, but I don't want platform specific. You shouldn't have to call your custom native modules differently based on your platform. The way you should, in my opinion, is how you should design them, is that they take the same arguments and the same methods. That way you have a much more consistent code base, and then just the implementation will be different. And that's what I would suggest would be the goal when you're working with multiple platforms, to have when you either it's a component or API, go as common as you could until the very, very lowest level and abstract all that stuff away. And especially naming. If you look at the documentation, for iOS, they'll use concepts like manager. They'll put manager like alert manager, calendar manager. And for Android, they'll put calendar module or calendar controller or something like that. Something different. I'm like, no, just keep it consistent. And keep it one way, and that way you'll have, in your JavaScript, you'll just know to always include that and reference it the same way. So I'm just going to do a quick demo of the application. I have it running in a simulator. This is it. Very, very straightforward, simple. There's a little, I don't know if you can see the little ripple effect when I scroll down. So that's what you get because you leverage the native module. I didn't have to enable ripple or anything like that, or put in some JavaScript to see where like when you're doing a browser app, you put like you see where your mouse points, where your
Scroll
mouse
stop,
like,
right?
yeah, and then start doing your CSS animation from there. You don't have to do all that. So it's nice. Then when you click here, this uses the native alert dialog for Android, which was a pain in the ass to get working. I spent the last 2 days trying to get that figured out. And I probably committed like sins in the Android world of getting it working, but I'll actually go into the code for that in a bit. But yeah, so you add the event to calendar, hit yes, it kicks off an intent, adds it to the calendar, cancel, goes back to the application, you keep doing what you're doing. So yeah, that's the app. It's relatively straightforward, it's simple. It didn't take me too much time to develop. It took me even less time to port it over. Let's continue. The basic steps if you want to add Android functionality to your app. If you have an existing app, we run React Native Android. That bootstraps all the Android stuff. It adds all the files, creates your index.android.js, blah, blah, blah. Then go through your JSX, look for anything that has the letters iOS, drop it, destroy it, because it's always going to break in the Android app. It's going to throw an unsupported component exception. So just drop it. Then run the application, see if it still works, see what's missing, see what's messed up. Obviously, there might be a lot, there might be not that much. So if you add anything that you dropped, you have to re-implement the Android specific version. This is where I spend most of my time, re-implementing the Android specific stuff. Same thing for if you had any native modules that required iOS. So for me, it was the calendar I had to. The calendar I had to re-implement, and the alert iOS. Now, activity indicator is the iOS progress spinner. In Android, it's called progress bar Android. I assume that somewhere down the road, the Facebook team is going to realize this and be like, hey, why don't we just call it progress bar and then have the Android specific and the iOS specific. They did it with Switch already before they had Switch iOS and Switch Android, so they combined it into one switch. So maybe they're probably just fighting over what name it should be. I don't know. I don't have an explanation for this, but just change the name. They have a little bit of a different arguments, fine, but you could abstract that away. So the alert iOS, at the time I originally did this, it was in development. From then, there have been a few open source releases that are excellent, and I recommend those probably over the one that I scratched together in a couple hours. So yeah, those are far better implementations. So the calendar API, like I mentioned earlier, the goal is to not have anything platform specific on the JavaScript side. Try to keep your JSX as close as possible. Obviously, you don't want, for example, if we move to the next design pattern in iOS, developer guidelines say stop using hamburgers. You don't want to have a hamburger, for example, but Android still supports it. That's a UI thing, fine. But in terms of your native modules that you're calling, try to keep them all the same. So as you see here on the top, I have my iOS implementation, and on the bottom is the Java one, the Android one. You see the method name is the same. The arguments are the same: name, string, date. Here I have it as a string. Here I have it as an NSDate. That's because iOS auto converts it. So that's just one of the gotchas. Android doesn't do that yet. Location, string, structure, string. Keep it as consistent as you could. If you do have to do some kind of specific stuff, like in the Java one, I have to parse the date and then bring it out into a date object. Just do that already in the implementation. Don't do it in your JavaScript. And to invoke it, just because you have it consistent, you see here, my iOS and Android files are the same in this regard. Like Jay showed earlier, we require native modules, and I have a calendar manager object available from it. And I just use the calendar manager, add event, and then the same arguments that I'm expecting. So on my iOS and Android, it's all the same. So it should make your life a little bit easier and your code a little bit cleaner. So that alert iOS. It has two options really for implementing it. You could either do it silent.
Good job.
Nice. Hopefully I didn't cut out the Wi-Fi. So good thing sound those electricity switch. You have two options. Either you could implement it entirely in JavaScript, so you make a pure React JSX component, and that does the alert. Because the alert's not really, there's nothing really native about it. It doesn't need to do anything complicated. Or you could use the native Android one. And the difference is, so the React way, you have a couple of benefits. Complete flexibility, do whatever you want with it. You could style it however you want. You could write any interaction, because you're implementing it from scratch essentially. And common code across platforms, because it's JavaScript. There's nothing platform specific anymore. You're doing it all in JavaScript, and then let React Native figure out the rest. The downside is you got to implement all the interactions. So you have to implement the buttons. You got to implement how I'm going to handle callbacks. I have to wire all that stuff up. I have to style all that stuff up. Someone like me, I hate CSS. I hate styling. I'm not good at it. So I would have to do that. Bother a designer. So not for my and possible performance implications. Remember, JavaScript is going to be slower than native. So in my opinion, it's better to let the native do whatever it could, and then you just manipulate it with JavaScript. Some examples though exist of this, and that's there's the React Native popover component and the modal component. They're excellent. They probably work really well. For something like an alert dialog, you might not see a big performance. The native way, the benefits you get are the platform consistent look and feel. Same reason why, like what I mentioned with the list view, you get all that. You get for Android, you get the material design look. Performance, you're running it natively. That component is being rendered natively. The bad side is, and this is a big one, writing native Android code for me. That was not fun. Like I said, I'm not a maybe for someone who does native Android full time, maybe it's not a big deal. For me, it was just a pain and limited flexibility. You could only do what the APIs provide. And there are some excellent examples already out there. React Native Dialogs gives you a lot of flexibility. Simple dialog, a little less features, but easier to implement. Material Dialog is the one that uses a third-party Android UI SDK, an Android native UI component for Material Dialogs.
Which one does it use? Which one does it use?
It's linked actually. It's actually called Material Native. This one, deprecated. Nice. Yeah, that's awesome. I guess we shouldn't use it anymore then. Make sure to mark that. Which is weird. It's like they made a wrapper. I guess because the native one really is material design for the latest. I guess if you're using an old Android, you want the material look. So here's the simple alert dialog wrapper that I scratched together really quick. Use it again. I like to call them manager, manager. So alert manager, and it exposes this function, this method, show alert. It takes a string of title, message. So if you want to pass in an array of stuff, it's a readable array in the Java world. And no, this does not extend array list. Why not? But it's its own thing. It's its own interface, and then you could loop it, and then but you could only get primitives from it, or other arrays, or maps. So it's a little bit weird like that. And a callback. I know Jay mentioned events earlier. I'm going to show you a little bit. You could do callbacks as well. So you could have actually Jay, you covered callbacks also, right?
Oh, yes.
Okay. Anyway. So this is the Java way of doing
They
callbacks.
call it class callback instead of
Yeah.
RCT response.
They're simpler here. The class names are much simpler here, actually. Except for this, we have context-based Java, but the the stuff you pass in React application context. It's a bit simpler here, but yeah, it's callback, and then you just I'll get into it. So there's a few parts here that the breakdown of the show alert. This is that alert dialog fragment. This is the class I had to write that extends dialog fragment that actually shows the alert dialog. Then we set the arguments using this bundle. I'm not sure if this is the right way, but when I was Googling it, that's what the recommended way was. And here we're setting the button callback. I'm just passing the callback because we're going to invoke it in the in that alert dialog class. And then finally you call show. Again, I'm not sure if this is the right way to do it, but the other libraries, they also seem to be passing around the main activity. So yeah, this is just the way I did it. I have a private property for the activity, which I set from the main React from the main activity. So this is the alert dialog fragment, and this is the implementation of that alert dialog. A couple of things. This is those arguments that I passed in earlier. So I'm using those for the message, the title, and I took that readable array and I looped it and I pulled out what the buttons were, and then I just needed the label, so I just set the labels for that positive button. That's why I have the ... here. It's just I do the same thing for negative or neutral buttons. That's just the implementation I chose. So that's why I check if there's a positive button label, then we're gonna set the positive button. And the second part of this is the callbacks. So I had the setter for the callback. And if you do have a callback, it's pretty straightforward to invoke the callback on the JavaScript side. Well, it tells it to invoke it on the JavaScript. You do the callback.invoke, and you pass in whatever you want, as long as it could be serialized over. So primitives or simple data structures, array lists, or arrays, or those objects, readable maps or readable array. We'll go back to it. And invoking it is also pretty straightforward. Now here I'm going a little bit different than what my iOS stuff is, because there we have the alert iOS, and that has its own API. You could set up your, I could have spent the time, and I should have set up my alert manager to take the same, same arguments. That's what, if this was a production app that I was working on, that's what I would have done. But in this case, you see here, this is what the method signature is, and here I'm calling it alert manager, show alert, message. And then here it's a little bit old school, I'm using function.bind. I think there's an ES6 shorthand now for it with the arrow functions, but anyway, I'm binding some information, and this is my callback on dialog button press. That returns true, so from back here, they invoke positive. I create the calendar event. So, summary. What did I learn? What were my trouble points? And what's coming next? So the iOS, as I mentioned, is their golden child, whatever. They put more love into it, and they've had about 12 releases or more now of maturity to build on that iOS foundation. The React Native Android part is catching up, and they're catching up faster, but there's still a bit of a difference. There's a documentation mismatch between because the developers who are working on the Android stuff are going to document what they're working on the Android, and the iOS developers are going to be doing what they're doing on iOS. So that's why you see like naming mismatches. Hopefully it'll eventually converge and be more consistent, but for now we just have to be a little bit more careful. More native modules are still to be implemented. There's obviously for example, the alerts. There's no reason why they should have alert iOS but not have the alert dialog implemented for Android. There's equivalent functionality. So, they're still working on that. And finally, better development tools. The iOS has awesome profilers that are just built into React, and they've already moved some of them over to Android, but just like showing the FPS, what's actually the FPS of the JavaScript stuff versus the native. So they're moving all that over to Android if they haven't already, mostly. Thank you. Finally, I want to open up for any final Q&A for myself and Jay. Any questions?
Where the hell are you guys?
Yeah.
When will the Windows OS presentation go up?
Windows OS. When they get a market share past 1%.
So have you tried, since there are a few different hardware architectures for Android, have you tried your code on different hardware architectures?
No, it supports I was just looking at it the other day, only because I was looking at this the other day, there's from what version it supports? Sorry. 4.1 and above. I'm not sure what if there was a hardware shift after that.
What I'm saying is that Intel, for
Yeah.
instance, is throwing money at the problem, so they're trying to talk people into using Intel processors.
On Android devices?
Yeah,
But isn't ARM still the standard?
it's more common,
Yeah,
but I don't know that I would say it's the
the
standard.
standard. Okay. I honestly, I've used it on the, actually, well, this isn't x86 architecture according to my emulator. So it is using Intel one. But I haven't heard of issues running across the different hardware architectures. Technically, as long as the UI is rendering consistently, because all React Native really is doing is translating the JavaScript through to C, and it's executing it through JavaScript core. So as long as that part works, and then it just tells the UI what to render. Because if you actually look at the messages it sends, it's just instructions saying, I have, for example, when you scroll, it says, I have this is the class, this is the instance ID, this is the event I'm firing, touch start, touch up. And this is the point, the physical location. Then in JavaScript core, translate that. Oh, you're saying you're firing it on RCT scroll view. Oh wait, that's scroll view manager in Android. And here's the method that you have to call. Scroll to, and here's the event. So as long as, then it's really up to the SDK and the operating system to. Well, thank you all again for showing up. Thank you for
Before I move that, so